Well, good afternoon, everybody, and welcome to the Center for Advanced Studies Spring 2019 Millercomm Lecture Series. I'm Evan DeLucia. I'm a professor in the Department of Plant Biology, and I also serve as the Baum Family Director for the Institute for Sustainability, Energy, and Environment, IC for short. Before we take a closer look at droughts across North America, I want to take a moment and talk about the Center for Advanced Studies, which has the mission to support extraordinary human and physical resources at this university by encouraging and promoting exemplary scholarship in all areas of knowledge. The center stewards a nearly $1 million endowment from the former U of I mathematics professor, George A. Miller, for whom the Millercomm Lecture is named. The money was given for the purpose of providing educational opportunities outside regular operating expenses. Dr. Miller is said to have remarked, "Everything I have received from the university, and I simply want to repay my obligation." And a bit about IC. Our research institute was created to bring the best minds on campus together at the University of Illinois together across departmental and disciplinary boundaries to tackle grand challenges facing society. The IC mission is to leverage the enormous academic strengths here at the university to conduct interdisciplinary research addressing wicked challenges in the areas of sustainability, energy, and environment, to help train the next generation of scholars and leaders in these areas and make campus a national model for sustainability. I will note that today we celebrated Urbana-Champaign and the university's Arbor Day. This is our 4th straight year as a Tree Campus USA. So we're moving in that direction very well. We are pleased to be part of Illinois' Earth Month festivities again this year and to also help present this lecture. Now, without further ado, I have the pleasure of introducing Dr. Jonathan Overpeck, our speaker this afternoon. He is the Samuel A. Graham Dean of the School of Environment and Sustainability at the University of Michigan. Dr. Overpeck's research on climate change and drought will be of particular interest to those of us in the Midwest who are watching the changes in our Midwest climate, changes in the North American climate, and changes in the climate of the world as we are celebrating Earth Week this week. As a world-renowned climatologist, he has published more than 210 papers on climate and environmental sciences, served as the lead author for the Nobel Prize-winning IPCC 4th Assessment in 2007, and also a lead author for the IPCC 5th Assessment in 2014. He has active climate research programs on 5 continents focused on understanding drought and megadrought dynamics the world over. And during his 17 years at the University of Arizona, also served as lead investigator of the climate assessment for the Southwest and the Southwest Climate Center, 2 major programs focused on regional climate adaptation. Dr. Overpeck has appeared and testified before Congress multiple times, and in addition to his numerous awards, he is a fellow of the American Geophysical Union and the American Association for the Advancement of Sciences. We're privileged to have him with us today to deliver this Millercomm Lecture entitled The Big Dry, New Drought Projections for the Southwest, Great Lakes, and Beyond. Please join me in welcoming John Overpeck.
Thanks, Evan. Hopefully my mic is working fine up there in the back row. We're good? Fantastic. It's wonderful to be here. And it's my first trip down into southern Illinois to this great university. I've been at the University of Michigan only for less than 2 years. And I'm a Westerner really at heart, but I grew up back in the Midwest, and it's wonderful to be back and learning about things like clouds and rain and trees and things we don't get so much in Tucson. But today what I want to do, obviously, is talk about what's going on out west. And I don't know if anyone knows where this picture is taken, but this is Lake Mead, one of the largest reservoirs, one of the 2 largest reservoirs in the country on the Colorado River. This is the river that provides water to, as you'll see in a minute, about 40 to 50 million people in the Southwest. But we're going to talk more broadly about not just this river and the other rivers of the Southwest, which I think are more of a canary in a mine shaft, but we're going to talk about their implications more broadly around the planet. And we'll branch out from there and try and in the end just to mention sort of what the threats are to the Great Lakes, but as you'll see, we can only do so much, and maybe there'll be some good questions and answers about topics more relevant to the Midwest and Great Lakes near the end here. All right, so I'm going to talk about global warming. I'm going to talk about climate change, and really talk about the fact that there's a lot of confidence now that climate change should be really our greatest concern when we're talking about water security in the Southwest United States, but also many other parts of the planet. And this is partly because of the proclivity in these regions for drought and mega drought. I'll define these later on. But what we're seeing increasingly around the planet now is literally climate change driven aridification. And you're seeing that coincident with essentially pumping out of groundwater that is fossil, meaning it accumulated over hundreds of thousands, millions of years, and we're using it up in a century. And once that's gone, we won't have one of our key buffers against drought. I'm going to focus mostly on the Southwest. I'm going to talk more about the planet and a little about the Great Lakes. I always like to start out with a slide that sort of highlights what's going on the planet and why we call it global warming. Because everywhere there's color on this map is where we have thermometers going back to 1880. And you can just see the trend in the amount of warming we've seen over the planet. And with very few exceptions, like in the North Atlantic, where we understand what is happening due to changes in ocean circulation, the whole planet is warming. And these gray areas in the polar regions, they're gray and not colored because we didn't have thermometers back in 1880. But I can tell you that particularly in the northern high latitudes, it's warming like nowhere else on the planet. And even in Antarctica, it's warming dramatically now. The warmest 5 years of this record are all in the last 5 years. Okay? In the United States, I like to think that there really are two sharp edges or issues related to climate change that will probably have the largest impact on our country. And this is arguable because there are other things going on, but one of the big ones is sea level rise. That's already starting to flood out some of our coastal communities and causing them to raise roads. And the U.S. Navy is changing all their infrastructure on the coast to account for perhaps up to 1 meter or 2 of sea level rise in this century. I'm not going to talk about sea level rise in this talk. Instead, I'm going to talk about water, because obviously water is really important to a lot of people. I'm going to focus on the Southwest. I'll try and highlight, though, of course, the broader implications. I want to start by talking about what's been going on in the Southwest. I moved to Tucson from Colorado in 1999. And in 1999, everything was pretty flush and wet, and water managers weren't worried about droughts at all, really, because they had an infrastructure, an amazing infrastructure, dams on rivers that was designed to be able to provide resilience in the face of drought. And immediately after arriving and starting to talk about drought, I can remember being at a meeting in Las Vegas when water managers were literally sort of chuckling when I talked about drought. But immediately after that, we went into a drought that continues to the present day. So we're in a drought that's in its 19th year. And I like to think about mega drought in the Southwest United States being defined as a multi-decadal drought, meaning 20 years or longer. So journalists have talked and called up and asked, are we in a mega drought? Are we in a mega drought? And all along I've been like, not yet, not yet. And the answer over the last 5 years is starting to dawn on me is, okay, this drought's going to go on for longer than 20 years, but we actually might not be in a mega drought. And you'll see what I mean in a minute. This year has been phenomenal in terms of snowpack in the Southwest. Any of you who are skiers know this. In January, this is what the drought looked like in the Southwest. And you can see in the four corners in particular of Colorado, New Mexico, Arizona, and Utah, there was extreme drought, exceptional drought even. And this is one of the real hot spots for drought in the Southwest and all of Arizona, really. And everyone in the room has heard about the droughts in California, and it was pretty darn dry going into the season. And then we just had a fabulous winter snowpack. And so now the drought region, it's much ameliorated. We don't have the extreme and exceptional drought anymore. We still see dry conditions in the four corners. But the headwaters up in the mountains, the Rocky Mountains, things are things are white. There's going to be a great runoff season. You can still ski if you want. But that's not the whole story. Is the drought over? No. Here, just to get a little more perspective, is how the drought has sort of moved around. And part of the story here is that droughts aren't just it gets dry and it stays dry for years and years or whatever and then gets wet again. That's what people like to think about drought. Drought being something that you get into, you hunker down, you have infrastructure and other coping strategies, and then you come out of the drought. That's not what we're in here, okay? You can see the drought really got going in around 1999, but you can see in 2002, 2004, were 2 years when the drought went, it started in Mexico, it kept deep into Mexico, went into Canada. It was a west-wide drought at first, and it moved out on the high plains like in 2012. It looked more like a Dust Bowl drought. In 2013, it looked more like a 1950s, 60s drought, really centered on New Mexico. And it's just moved around. And one of the interesting things being in Arizona is it was always in Arizona. So we're actually one of the best years of this 19-year drought is like right now in Arizona. Okay. Some people are trying to say, hey, we're out of the drought. No way, we're not out of the drought. There are different definitions of drought. There's meteorological drought, that's is rain falling, or is rain and snow falling, or is it not falling? So we had a good winter year, so we're not necessarily in a meteorological drought right now. Agricultural drought, not so much either, because we had a really good snow season and a lot of our agriculture out there is all irrigated ag, so ag's in good shape. Hydrologic drought, hell yeah, we're still in drought. And here's a good demonstration of that. Just this month, whoopsie daisy, just this month the president signed, Congress passed and the president signed a drought contingency plan. So the lower basin states of California, Nevada, and Arizona have agreed how to share water shortages starting now so that they can keep this lake, this is another view of Lake Mead here, they're both in these newspaper articles, keep this lake from going below a shortage level, which we're just hovering above right now. And once it goes into a shortage, then water curtailments will be much larger than they will be in this drought contingency plan. Okay. Now I'm talking about the Colorado, and it probably pays off for all of you if I talk a little about what this basin looks like. As you can see, this is the Colorado River Basin, and this light tan color goes all the way up into Wyoming, 7 basin states, and Mexico share the water. But what people don't realize is that a lot of the biggest cities in the Southwest, including San Diego, Vegas, LA, Salt Lake, Denver, Santa Fe, Albuquerque, they're not in the basin per se, but they're all using water from this from this basin. And these 2 lakes are a big part of that. Phoenix and Tucson are in the basin. This is the sustainable water supply for those cities. And about 40 to 50 million people, depending on how you look at it, use water from this river. It's the fastest growing part of the country. I should have pointed out that Tucson, Arizona now, we just learned this year, is the fastest warming part of the country. Many large cities, all your winter crops, vegetables. If they're not coming from Mexico or South America or New Zealand, say, most of our winter vegetables are coming from down here in the Yuma region and over here in the Imperial Valley of Southern California. Many native nations share this water, but this is the only renewable water supply of the Southwest. This and the other rivers that have their headwaters in the mountain snow-rich, when there's a good winter, mountains of the Southwest, mostly in Colorado and Utah, but also in the northern part of Arizona and New Mexico. All right? Just to give you a sense of why we say we're still in drought and most of the water managers are not resting easy in the Southwest, is these big reservoirs like Powell and Mead, the 2 largest reservoirs in the country, completely full in 1999. Powell is only 37% full now, and Mead is 42% full. These lakes were going to fill up a little, but it's still going to be well below 50% full by the end of the runoff season. Okay. Now I have some graphs in here, and it pays to look at some actual data. but I'm going to try and make it easy on us. First, I'd like to just start and look at the actual volume, the combined volume of water in Lake Powell and Lake Mead. These are the two primary storage units. They dwarf all the others on the Colorado River. They are the biggest in the United States. And the dam building began, as you probably all know, back in the Depression era with the building of Boulder Dam, which then became known as Hoover Dam, and now is again Boulder Dam, that dammed up Lake Mead here in the 30s. And they filled up that lake pretty quickly to essentially allow some cities in the Southwest to start to thrive and also to really encourage agriculture in this part of the country and settlement. And things were doing pretty well in terms of storage until the 50s, and then they had the Drought of Record. And as you'll see, this is a precipitation drought that occurred in the 50s and 60s, and it really caused the lake to drop, and things were looking like troubling, and they said, oh, we need more dams. And those of you who follow history of the Southwest know this is when there were big battles going on. They wanted to put a pile of dams in the Grand Canyon, and the Sierra Club was running ads in the New York Times saying, would you flood the Sistine Chapel? And they were able to keep the biggest dams in the Grand Canyon from being built, but we still ended up building the Glen Canyon Dam. And then that allowed more storage to be filled up, and everything was hunky-dory by the 1980s, small drought here in the late 80s, 90s, and then 1999, and then it plummeted. And they've been able to keep it at this sort of sub 50% full level for quite some time by curtailing the use of the water and by having a couple good winters. But more often than not, it's been a bad winter. You can see down here, and we're using these million acre feet units. Isn't that wonderful? These are not metric, as you already probably guessed, but these are the units that water managers in the Southwest use, and an acre foot is a lot of water. And so now what we're looking at, and we're going to see in the next slide a number of other graphs. In each case, we're looking at the gray line, which is the year-to-year flow, annual flows. And you can see there's a lot of variability, up and down, up and down, up and down. And in the blue line, we're looking at the low frequency component of this, so the slowly evolving. This was a wet couple of decades here in the 1920s. Ironically, that's when they divided up the Colorado River water and gave everyone their allocation. Was the wettest time, we think, in 1,000 years. Little trick by God, I guess. And then what we're also looking at is a straight line in each of these plots, the dashed red line, which is the trend, the long-term trend. And you can see that although there have been good years and bad years, and there are the bad years during the 1950s drought, and a couple other bad years, and then a bunch of bad years during the current drought, the overall trend since the records began of measuring the river flows has been down, 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 okay? Now, what caused that? And most people, and I got to admit, when I got into this business, I was thinking, when you get a drought, it's a lack of rain, a lack of snow. So let's look at precipitation. This is precipitation here again, and I'm using all English units, and I'll stop doing that in a minute, but this is what water managers use in the Southwest. Here's the precipitation record in the headwaters of the Colorado River, and the Rio Grande for that matter. And we're going up and down, as you can see in the gray line, and then you look at the slowly evolving blue line, you can see during the 1950s drought, that was just a bunch of really kind of dry years. And there was a lot of vegetation killed during those years, and we'll talk about that later. Then things got wet again, and then we got into the current drought. And even though there were some really bad dry years, early 2000s, there have been some good years too. And this only goes up to 2014. And the same pattern continues, but there really has only been about a 3% decrease in precipitation during the current drought compared to a much larger decrease in precipitation during the 1950s, 60s drought. The big surprise is when you look at temperature, okay? Because look at precipitation, the long-term trend in precipitation, that dashed red line is flat. Look at the natural flow, the long dashed line is down. Okay, less and less flow. If you look at temperature, what you see is the mirror image of the natural flow. Warming, 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 warming. And indeed, this drought that we're in now is characterized not so much by below normal flow, but by warmer temperatures. It seems simple, right? And every half of you are probably thinking, what's the big deal here? Isn't that obvious? You know, anyone who has a garden knows that when it gets hotter, you need to put more water on your garden. And that's because the atmosphere is soaking up more, taking up more of that moisture via evaporation, evapotranspiration, and other things. So what we think is going on, and it's been tested now in a number of studies that are in the peer-reviewed literature, is temperature is the more demanding part of this whole story, and temperature is driving not necessarily just a drought, but an aridification of the Southwest. We're not going to come out of this unless we start to get some really wet years. Okay? What's been driving this aridification is this global warming. You know, and the Southwest we now know is warming more than any other part of the United States, and it's driving a drier and drier conditions in the two biggest rivers, the Colorado and the Rio Grande, as well as some of the smaller rivers of the Southwest. Okay, so where's all that water going? I've kind of alluded to that already. As the atmosphere warms up, it can hold more water. So it's demanding more water. And again, everyone knows that who gardens. There's more evaporation. There's more evapotranspiration, meaning the water moving through the plants and out the pores in the leaves, the stomata, is going into the atmosphere. And the atmosphere, because it can hold more moisture, is demanding more of that moisture as it warms up. And there are many terms that go into that. I've talked about more evaporation. I've talked about evapotranspiration. This is the big term in the Colorado River Basin, because you're actually getting a much longer growing season now, 6 weeks longer in the upper basin. So plants are starting to move water from the soil into the atmosphere much earlier. Of course, the snow is melting earlier, so it too is going into the soil and it is going into the atmosphere earlier. But there are other things going on too. People who study snow know that it can, as you get warmer winters, you're also getting moisture being transported directly from the frozen state into the vapor state in winter. And you have a few other things going on that all collectively contribute to warmer, less water in the river. Okay. We wrote about this, I wrote about this, a number of people are writing about it now, is the challenge of hot drought. This is not like the drought of yore. And as a paleoclimatologist who studies these hydroclimatic systems, this is a point we started to really hammer back as early as the beginning of this century. But now it's got some real traction in the climate change community as being a real threat, and you'll see why. Okay. So are we really in a drought? No. Some of this could be natural variability and less precipitation, a little less. But it's really more aridification due to a very clear trend in warming temperatures. Okay? Is it a mega drought? You could start calling that a mega drought as it enters in its 20th year, but it's also probably not doing it justice to just say it's a mega drought, because that conveys that we're going to come out of it like mega droughts of yore. This is a drought that we're not going to come out of. We're going to drive this river to less and less flow unless we stop the warming. And when we stop the warming, we're probably going to have flow on average that is that much less at that point. And of course, there'll be variability around that. But we are drying out the Southwest, the lifeblood of the Southwest. The question is, how much can we dry it out? This is the bigger question. What's the cost we pay if we don't do anything about climate change? And there have been quite a few studies on this, and every study has revealed that climate change should reduce the flow. And before we started the work a number of years ago focused on this, the range of the literature was maybe it's only 1% less flow by the end of the century, or by mid-century, 2050, or maybe it's 45% less flow, or maybe it's somewhere in between. So we wanted to reconcile this. So what we did is we got all the scientists we could together who had written papers on this, and we started this project to reconcile all our estimates, to use common assumptions and really figure out what the best estimate is and what the uncertainty is in our estimate of flow reduction for a given amount of warming into the future. And this is important. One of the things that's critical in doing this is to recognize that we don't really know how much it's going to warm. We know it's going to warm as long as we put greenhouse gases in the atmosphere. That is, we know with as good certainty as science gives you. It's like guaranteed. I'll bet my house on it. But I can't tell you how much it's going to warm. Okay, and we use climate models to get an idea of what the range is for a given amount of greenhouse gas emission. The biggest uncertainty is actually how much more greenhouse gas will we put in the atmosphere. If we assume business as usual, putting emissions into the atmosphere as we're doing today, the coolest models suggest a 4 to 5 degrees warming by the end of the century. The warmest models say, nah, it's probably 4 to 7. These are degrees C, so multiplying by 1 by 8, almost 2 to get degrees Fahrenheit. And the middle range models, they're saying, well, it's going to get pretty warm, closer to the warmest. All right? So there's a lot of warming yet. We've warmed up about 1 degree C so far, 1.5 degrees C in the Southwest. Okay? So this was a pretty big study. All these authors came together to get a number. And it's in this Bulletin of the American Meteorological Society, and they got the cover because this has a big deal. And Julie Vano led this study. And in this study, we did a number of things. We talked about all the different sources of uncertainty. And we came up with an estimate of how much decline in Colorado River flow would you get per degree C warming. Okay? We talked about precipitation too. But if there's stable precipitation, how much will we get just because of the temperature factor? And we came up with this range, best estimate, 2014, of 6.5% plus or minus 3.5%, one standard deviation, per degree C warming. So somewhere between 3 and 10% river flow reduction. And based on our actual observations of the Colorado, it appears the number's closer to the upper end of this estimate, and certainly isn't at the lower end. And now, there have been a couple studies that have taken that and used it to estimate what's going to happen in the future. And the story only gets kind of grimmer the more work that is done. But basically, by the end of this century, we could easily consume 50% or more of the river flow if we allow greenhouse gases to keep going up at the rate they're going up. We've already probably lost about 10% due to warming. All right? And this is a study that Brad Udall led that I worked on with him. There's another study that Brad's involved in with Dennis Lettenmeyer and a student. Dennis is a very famous hydroclimatologist working on hydrologic problems, and their estimates are worse, i.e. bigger. Okay? But what's the big deal? Often I give this talk in the very red state of Arizona or in the very hopeful state of Nevada, and people are like, well, we think it's going to get wetter. This is not a big deal because we know some of these climate models say it's going to get wetter. All right? Would you want to bet on that helping us? First and foremost, yeah, some of the models say it's going to get wetter. What does Mother Nature say, however? Remember, these models, some say wetter, some say drier, some say no change. Mother Nature has been flat over the last 100+ years. So it doesn't look like it's getting any wetter, but that could just be natural variability, and all of a sudden it could start getting wetter. Wouldn't that be nice? Are you going to bet on it, though? Okay? Don't bet on it. Bad bet. Okay? But if you like going to Vegas, you might want to bet on it. All right? It might not matter, however. And this is a really important point. And it's, as you'll see in a minute, it's a good point for not just the Southwest North America. This problem extends down into Mexico too. This is a problem for all drought-prone places in the world, where you're getting big decreases in water availability and river flow because of warming. And the problem is it might not matter what precipitation does, mean annual precipitation does. Why? Because in most of these regions that are semi-arid to arid, they have a rich and deep history of drought. Droughts that last 5 years, droughts that last 10 years. Some cases, like in Africa, I'll show you in a minute, or Australia, droughts that last many, many decades have occurred in the last 2,000 years. What happens if you get an increase in mean annual precipitation and then you get a drought that lasts for 30 years? It's like having a decrease in precipitation plus the full effect of the temperature. Southwest is a drought-prone part of the world. One of my students, Cody Roteson, is now at Northern Arizona, and Connie Woodhouse, who's a famous tree ring hydroclimatologist, was studying bristlecone pines in the headwaters of the Rio Grande. It's shared headwaters in southern Colorado, of the Colorado River as well. The longest drought we found in the Southwest, think Mesa Verde or Chaco Canyon if you want a little graphic of what happens when it gets too dry in the Southwest. People have to move, okay? The longest drought we've seen, and there have been many mega droughts that last multiple decades in the Southwest over the last 2,000 years, but the longest one we found is 50 years with 1 year above normal. And I show this to water managers when we first finished this, and no water manager I've met knows what they would do. They're engineers, they're used to solving problems. We don't have a solution to this problem based on engineering or infrastructure. This is a serious problem. It's a serious problem because if you get a drought that lasts 50 years, it's game over. But even a 25-year-long drought, there's a very serious risk that we get a 25-year-long drought or a 50-year-long drought. These are estimates that we've got using paleoclimatic data to bias correct our climate models. Toby Alt's a professor at Cornell now, another former student. And these are pretty serious numbers. I mean, you cannot bet on not getting a mega drought in this century, okay? And as I said, you could get 50% or more reduction due to the warming. Well, during one of these mega droughts, you're likely to get about a 15% reduction below current flow because of the reduction in precipitation during a mega drought, if the mega drought is like the mega droughts that have happened repeatedly in the past. So you can see that the very lifeblood of the Southwest is threatened. These droughts are going to occur probably no matter what. They're made more likely because of warming, as that Alt et al. Literature says. But this term here, totally within our control to stop or not. If we don't want that big decrease in flow, all we have to do, Peck says, is stop global warming. This is the reason, for example, why California, they have many reasons, but why California is so serious about let's stop global warming. This is the reason why Colorado is starting to say, let's stop global warming. This is the reason that New Mexico has decided to go carbon neutral. Arizona, Utah, not so much. But they're the ones that have the biggest reason to do this because they're going to run out of water if they don't, or they're going to have to really downsize. Okay. But it's not just about the water, and probably everyone in the room knows that the news that's been coming out of the West, of course, water, if you pay attention, it's really been coming out, but we have this wonderful infrastructure, the dams and everything, that so far have maintained status quo in the Southwest. And what I'm here to say is that beautiful infrastructure is going to be overwhelmed soon. We'll be overwhelmed by 2021, or it'll be overwhelmed by 2025. The point is it's going to be overwhelmed soon. But it's not just about the water. The other thing that's happening in the West, it's crystal clear, as things warm, it sucks the water out of the soil and vegetation. We've already talked about that. It dries things out. What happens when you dry out soil and vegetation? You get tree mortality and death, okay? You can see here, this is in the Four Corners in 2002. There are these large expanses. One of the largest biomes in the West is pinyon juniper pine. Pinyon pine and juniper woodland, sorry. And you can see a whole bunch of dead pinon pine, and the live trees are the junipers. You go back 2 years later and you can see the dead trees, and you can still see there's juniper on the landscape, but the pinons have died. They died initially just because it was too hot and dry. And that's undoubtedly happened in the past, but it really shocked everyone that the trees could literally up and die. And of course, much of the West is being affected when this happens. Trees get weakened by the hot, dry conditions, and then insects or pests come in and kill the trees. In this case, the trees started dying out right before the insects and pests made it worse. California drought that's been going on more recently has killed huge swaths of trees, including some of the biggest trees in North America. And there are lots of pictures like this now. Okay? And of course, what you've been hearing about most, if you're paying attention at all, are the wildfires. The biggest, most catastrophic wildfires are becoming much more common in the Southwest. This one being one of two big fires last summer on two sides of where we have a cabin in Colorado. We had some days that just look like, very scary. But this is happening more and more in the West. Okay. Just this week, if anyone reads New York Times, there was a story, and I was like, whoa, what's this? And it was focused on Rhode Island, of all places, where I went to grad school. And the trees there are dying. And of course, if you're paying attention to what's happening throughout the eastern United States, you're starting to see trees increasingly get stressed and succumbing to pests and pathogens. It's not like out west yet, but it appears to be going in that direction. And that's not surprising, and I'll come back to that in just a second. First, I want to talk about how this is not just a problem for North America, it's a problem for the world. And what we're looking at here is a map based on model projections of where we're likely to get drought in the future. all these darker red and orange and brown colors are where we know, based on observations and paleoclimate data, and climate models simulations. These are the drought-prone regions of the planet. There's a lot of really sort of no surprises on this map. So for example, this is the most drought-prone part of North America. Australia, really the big dry, that's what they talked about in Australia, their drought around the start of the millennium. Parts of Africa, there are parts where the models don't simulate big drought risk, but we know there is big drought risk on the Horn of Africa and across the Sahel. The Mediterranean is one of those regions that's very drought prone, and of course it was the worst drought on record in Syria that contributed to the start of the big crisis there recently. And China has a serious drought risk, as does India. India doesn't really show up in the climate models simulations as a drought-prone region. But here I've superimposed our work on either reconstructing drought or looking at the literature, and you can see the length of megadroughts that have occurred recently in each of these regions. Lo and behold, I'll start over here in the Amazon, some area that we just weren't thinking about. The longest drought that's ever occurred in the Amazon on the very short rain gauge record is just 1 year. 1 year. And of course, people are like worried if a drought happens there. But what happens if you get a drought that lasts 10 or 15 years? We see that happen repeatedly in the paleoclimatic record that we've created. That means you could really dry out the Amazon to the point you could burn out the Amazon. And anyone who follows what's happening in Indonesia, where they also have rainforests, when they get a dry year, a lot of times the wildfires start taking out, huge expanses of rainforest. Orangutan are not happy, but the palm farmers are. i.e., even if you don't allow wildfire and you put wildfire out, if you get dry enough conditions and there are people who want the wildfire to start for whatever reason, it will be very conducive to that. Look at Australia, where droughts longer than 100 years have happened in recent history. Look at this part of Africa, where the simulations don't really show it, but we've had droughts in excess of 100 years. And really, the only mega drought we've seen on this planet so far in the instrumental record was the Sahel drought of the 70s, 80s, and 90s. Okay? Our part of the world up here, 50, even 100-year-long drought over here in California. All right? I looked at the literature for Great Lakes in Eastern North America. Droughts happen there. They're much less frequent. But in the last 1,000 years, there have been 3 droughts in the Great Lakes region that lasted 20 years or longer. So this is a global problem. And during these drought periods that can last multiple decades, the full effect of the temperature is going to play a role. And so you can really imagine what it's going to do to the vegetation and water resources, not just in the Southwest, but in many parts of the world. Okay? Lo and behold, there are the scientists who study tree mortality, forest dieback, death. And this is a compilation that we did for the IPCC 2014 report based on what Craig Allen and Dave Brashears and his colleagues have done already. And all of these dots, red and white both, they're all showing where there's been substantial drought and heat-induced tree mortality around the planet. And you see it really clearly in North America and Eurasia and Europe. These are the places where people are studying it. The places where there are fewer dots, I think, are more because people just haven't been looking. And there's a funny story, not funny, but there's an interesting story in international climate diplomacy about leaders in Africa not wanting to have this graphic in the summary for policymakers of the IPCC, a very short document that goes to everyone at the highest levels, because there are fewer dots in Africa. The reason there are fewer dots is not because there isn't a problem there, it's because there haven't been enough studies there. So last year we published another paper that was multiple years in the making. And what we did in this study, led by Connor Nolan, who's going to just defended his PhD, is going to Stanford for his postdoc. Steve Jackson and I led this, but we had dozens of colleagues around the world, and we compiled all the vegetation data paleovegetation data over the last deglaciation. And the reason we were looking at that is because over the last deglaciation, the planet warmed substantially, and there was vegetation change that was substantial. And we wanted to look at how might that give us inform what might happen in the future. In other words, the last time the planet warmed up a lot, from ice age to interglacial, was this period from about 20,000 to 15,000 to 9,000 years ago. And we're going to get a lot of warming into the future. And you can go look at the paper, but what we were able to show through a lot of work of a lot of scientists, particularly Connor, is that if we allow emissions to continue as business as usual, there's an 80% chance that land cover almost on every land surface of the planet, out where there's vegetation anyhow, an 80% chance that there will be a 80% chance of large change in the composition and structure of the vegetation, meaning the vegetation has to change dramatically. And I think what's happening in the Southwest and at these other areas where we're starting to see it around the planet is literally the first signs of this transformation taking place. And it's not, as previously thought, going to only affect certain parts of the planet. It's going to affect everywhere. Whereas if we were able to curb emissions to the level agreed upon in the Paris Agreement, there's a much lower chance that there'll be this whole-scale transformation. Sure, it'll still happen in some places, but there'll be many more places where it doesn't occur. I think if we let climate change go unchecked, of course the Midwest, the forests of the Midwest, the forests of eastern United States will be in the same shape that the forests of the West are already in, meaning it's going to be a lot of forest mortality, it's going to be a lot of wildfire and other types of disturbance as the vegetation tries to adjust to its new, much warmer climate. And of course, this has huge implications for carbon storage, for water services that ecosystems provide, for biodiversity, and a whole lot else. All right, so let's take a breather for a second. And hopefully these are some of the points that you've all sort of gotten the point. Climate change impacts and costs are really mounting fast. This stuff is coming on much faster now. You can hear the train on the tracks. You can see the light down the tracks, and it's coming at you full speed ahead. The thing that's really most remarkable about what I'm talking about here is these are the changes in water and land surface impacts that are driven by temperature change. And when you're talking about climate change, there are some things we know extremely well and some things we know less well. One of the things we know extremely well, as long as we put greenhouse gases in the atmosphere and increase the concentrations, we're at about 410 parts per million now, CO2, and there's these other greenhouse gases as well, like methane and nitrous oxide. As long as we keep putting those up, it will get warmer. Bet your house on it. You will win the bet. There are other things like precipitation. Little uncertain about where it will rain more and where it will rain less. Okay, but the things I've just showed you, they're driven by temperature, high confidence. What about the Great Lakes? Well, I don't have a lot of time left today to talk about the Great Lakes, but I'm happy to answer more questions if you want to ask me. Hint, hint. Okay? But I want to show an interesting graphic because I think it pertains to, the future of Illinois, Michigan, but even more, of course, what's, parts to the south of us. This is an interesting study that was done by a number of authors, published 2 years ago, looking at the costs of various climate change on various sectors. Notice what's not in this list. Hydroclimate, running out of water in the Southwest. Sea level rise, flooding this coast all the way along here. I'm not talking about the costs associated with that, and I would maintain those will be the biggest costs. We're not talking about just how damn hot it's going to be over most of the year down in this tier of this country. But we're talking about the impacts of climate change on agriculture, crime, hurricanes, and other coastal storms. They're getting a lot more damaging now. The costs on energy production as it gets hotter, human mortality, labor. It's hard. People have to work outside. It's harder and harder to do in this tier. And you can see that the projected hits to gross domestic product at the county level are high down and across the southern tier of the United States and as far north as where we are now. And they get less high as you go further north. I might be one of the first climate refugees in my family. We moved, Francina Dominguez is here too. We moved, Jessica Conroy, we moved from here up to here. The question, did you move far enough north? It's a very interesting point. Lo and behold, the Great Lakes. 20% of the world's unfrozen fresh water. I like to show this when I give talks all around the Great Lakes. You're a Great Lakes state, because this is an amazing resource. And we have to figure out in advance how we're going to use this resource and how it might allow us to adapt to climate change and what the limits are to adapting to climate change. Now, I know Illinois has signed the Climate Alliance, meaning Illinois as a state is now in with Paris. Michigan is in on it with that. Wisconsin, who would have believed? Minnesota, Pennsylvania, New York. A lot of the Great Lakes states have agreed, Canada, another country, right? That we need to do something about climate change. But there are limits to what this amazing water resource can provide as the aquifers on the high plains, let alone the Southwest, dry out because we're over pumping them. And we no longer have the buffer for this heat-induced reduction in water availability. We become water insecure. And this is, of course, a global problem, but I think it's a problem for the Great Lakes. On one hand, near term, if climate change isn't that bad, I think a lot of people will move to this part of the world. That could be good for our economy if we handle it right and plan accordingly. But we too could really suffer if climate change is unmitigated. And I can say more about that if anyone has questions. Okay? So the bottom line here is that climate is rapidly reaching the crisis stage. Causes are very well understood. Anyone who tells you it isn't is probably getting money from the fossil fuel industry or just not paying attention. And the future changes are likely to be large. We know that well, unless we reduce greenhouse gas emissions. Impacts will be huge without rapid action. The question is how rapid is needed. But the impacts will be modest if we act fast. And there are many co-benefits of acting. You know, one of these is obviously cheaper energy. We're likely that renewable energy, the prices are plummeting as I speak. It's going to be cheaper than fossil fuel energy. Of course, the air will be cleaner. Methane alone is going to increase tropospheric or lower atmosphere ozone levels back to the levels they were in the 1970s. Do you remember that? If we keep going with natural gas. But we can get clean air if we just get out of fossil fuels. Clean water, no more fracking. That will be good for our aquifers. And a more sustainable and just economy. That's essentially the Green New Deal. But we also get in a position in the United States to compete, to provide the solutions, renewable energy and energy efficiency and much more, hopefully sustainable agriculture, to the whole planet, because the whole planet is getting out of fossil fuels. So you can start to think of this not as an environmental problem, but as an economic problem. Do we want to be economic winners? That's what we will be if we act, or economic losers if we decide to let this keep on going. We may be less a loser up in Michigan than down in Arizona, but still, it could get bad. Here's some of those questions I've tried to sort of give you a sense of. Would we be a winner? Is there reason for hope? Yes, there is. Any of these things I'm happy to talk about. But for now, I'll just stop. I'll highlight, I tweet about all of this stuff. So if you want regular updates, just follow me on Twitter. I'd be very interested in hearing your opinions too. Thank you.
So Professor Overpeck is happy to take some questions. He's hinted that questions on the straight legs might be appropriate. But we have a couple of runs with microphones, so please raise your hands. You have a mic?
If you could yell it out even, and I'll just say it again.
I will yell it out. So your call, of course, to deal with climate change is spot on. According to the U.S. Department of Agriculture, roughly 80% of all consumptive water use in the United States is due to irrigated agriculture. In much of the West, the dry part, that takes up 90%. Yes, some of that water goes for vegetables and orchards and so on. That's roughly 1/6. 5/6 of it goes to very low-valued agriculture that is largely in oversupply in the United States. It sure seems to me like we need a dramatic curtailment of irrigated agriculture. Do you think that's right? And not that that's going to increase the water flow, but it certainly would decrease the demand for water. And if so, why is that issue just not on the agenda in the Western United States?
It is on the agenda. It's happening. That drought contingency plan that I mentioned, that is just signed by the president, and it had bipartisan support in Congress. You don't see that too often. It is a big part of that is curtailing irrigated ag. You're absolutely spot on, 70%, 75% of water use in Arizona is ag, is irrigated ag. There are huge groundwater reserves, ironically, in Arizona. They're not so big in other states in the Southwest. So what we'll see is we're saying you can't use the Colorado River water for irrigated ag, and they're paying the farmers. The farmers are going to use that money to turn on the pumps, and they're going to start pumping the groundwater. So in a sense, the irrigated ag will continue, but the problem is that that water is fossil water, and it will just get more and more expensive to pump it, and then it'll be gone. So it's like looking at renewables versus fossil fuels. The market is going to drive the change that you described. Irrigated ag in the Southwest is going to be history. That said, some of the senior water rights on the Colorado are owned by the farmers, particularly in Yuma and the Imperial Valley. So it'll be interesting to see. I've gotten to know a lot of those guys, men and women, mostly men who run those farms. And I think they're genuinely hope that they can keep in production as a way of life for them and their families. But I think a lot of them also realize that they'll reach a point where that water is so darn valuable that they might as well cash out and become millionaires. You're also starting to see some of those farms in that neck of the woods, particularly in the Imperial Valley, go fallow and instead go to solar farms. And so those farmers are realizing that, hey, I can make a lot of money selling my water rights, and I can install solar and make even more money. So I think we'll start seeing that more and more. On the High Plains, that whole story is not being well told either, because there again, I think it's going to be very hard in the future to continue pumping indefinitely because the water is fossil, and it will not. You cannot get more water into the ground fast enough. You can't recharge it. So it's only a matter of time before some of our biggest aquifers are no longer able to support irrigated ag. So we better start doing what you said, is thinking about what's the best agricultural use for our water, and let's not waste it, because that is our buffer when we get drier and drier conditions. Do we want to be a country where we have to import food? That's, particularly in winter, that is what we'll have to start doing. I won't pick them. I will pick them. You got the microphone. Whoever gets the microphone gets to ask.
So obviously, as water becomes more scarce, there's going to be a lot of different social justice and equity issues that are going to arise from that. Can you speak to that at all, and any sort of plan to help mitigate those effects?
This is critical, and this is why I know a lot of people read about the Green New Deal. What is the new Green Deal? And there's all these hogwash things about, oh, you can't eat beef and you can't fly, this and that. What the Green New Deal is all about is thinking about solutions. There are some solutions, for example, let's just go with nuclear or geoengineering, and I could tell you why those are not good solutions on their own, but they're solutions that come straight from the sort of current way of thinking about solving problems. Let a few really wealthy corporations solve the problem for us, and all will be good. The Green New Deal is all about, let's instead figure out how everyone can benefit from the solution, so that the new world we create, powered by clean energy, is one that everyone benefits by, not just a few. That is the essence of that. But let's look in the Southwest, where I think you're probably thinking, where one of the obvious solutions that's talked a lot about by colleagues I've worked with is, let's let the market do the work and just put a more realistic price on water. Right now, water is so damn cheap in the Southwest. That's one reason it's going into these really low value crops and things. It really costs nothing. And so the US government heavily subsidizes, obviously, all of this water and energy. So the problem with that, of course, is there are a lot of folks who have traditionally used water, say on the Rio Grande and in the acequias there, that were created back in the 16th century and since then. And is it right to say, take a water from these families and communities that have long been using the water and force them to just get another way of making a living? Some of them might feel good about selling out, but a lot of them won't feel good about being forced to sell out. Because let's say you want to grow nut trees and you're going to pump the groundwater, and when you pump the groundwater next to a big river, the river levels go down, and these traditional ways of doing irrigated and ditch irrigation, they just dry up. So I think there are a lot of reasons why, and you see this in California, arguably the most successful climate action on the planet. They're paying a lot more attention after a few false starts to environmental justice. If you don't pay attention, you don't get the political support, and it'll fall apart. If you do pay attention, you'll get the political support. And again, that's what the Green Deal is all about. Green New Deal is getting the votes Why do you need the votes from so many people? In part because we're going, this whole problem requires going up against the biggest, richest industry the planet has ever known. Oil and gas, they're not going to give up easy. They're going to spend and do whatever they can to maintain the status quo. And the only way we're going to break through that is if we can demonstrate the value, the benefit to every American in making this transition. And there are probably not a lot of Americans who are not like folks in this room who have been thinking a lot about it. And we need to let them think a lot about it and see how they get to chart the roadmap to the future and benefit from that. You got the microphone, but keep your hand up. I bet you'll get it next.
Thanks so much for coming and talking to us today. So you had mentioned, the need to drastically reduce our carbon emissions, obviously for a number of reasons. My question is, an ideal way to do this, right, is to increase the penetration of renewable energy in our power sector, but that increases the need for clean ways to store that energy. And currently the best way we've got in doing that is with pumped hydro storage or dams. And so I guess my question to you is, from your academic perspective, what are the pros and cons of using dams or pumped hydro storage to increase the penetration of intermittent renewables?
Right, so people know what he's talking about. We actually do pump storage up in Michigan where, but we don't use it for renewables. During the day when your sun is shining or when the wind is blowing, you can pump the water uphill. And then you can, when the sun isn't shining or the wind isn't blowing, you can let the water flow back down. And you can generate energy as you're pumping up and pumping down. And that gives you some storage capacity. I have no problem with this. I think if you're going to really start doing this on a wide scale, say in a lot of rivers with micro turbines, I think that's what they're called. I don't know what they're called exactly. You're going to have to really pay attention to aquatic ecology and do this in a way that's it's very careful. On the other hand, I don't think it's going to be needed. I think battery storage is within 5 years of being economic at the scale we need. And that will take care of the problem. We will have industrial scale, utility scale battery storage. And at first we'll see as that gets penetrates the market, it will be obviously augmented by natural gas, peaker plants and things. It turns out that natural gas isn't nearly as carbon friendly as we thought. And increasingly the science is making it clear that because the industry refuses to prevent leakage at the wellhead and during transport of natural gas, the hit to our climate system is almost as bad as coal. And it's simply because the industry refuses to solve this problem. And that's an interesting observation. So natural gas is not the best bridge to the future. But it's all we got right now. But within 5 years, I think that period will be over. So why do I think it'll be over? Why do I think the prices will keep falling? Because every single nation of the world is interested in making this transition, has signed on to the Paris Climate Agreement except Western Sierra. And that means there's a huge market. And so then the question is, who's going to benefit from that huge market in renewable energy, in battery storage technology, in efficiency, in more sustainable agriculture, all the different innovations, knowledge, and technology that's necessary. Who's going to benefit from that? China? Right now, they're clearly aligning their economy to do that. The US? Well, a lot of states are actually stepping up to do that. And I think in the Great Lakes region, we'll step up. But I worry, because the federal government is stepping backwards on this. And this might really be a big hit to us economically as we move forward. But because the market is so damn huge, the prices are going to continue to plummet for renewable energy and battery storage. So I think that's the future. You got to get these guys to come down here too. Yes?
Well, I was curious if, are there ways of, that are in action or being thought about of mitigating a water shortage by enhancing the water collection in parts of the country that virtually make water, like on Mount Hood, the dam that's there, like increasing that capacity to collect the water that comes in from the Pacific?
Yeah, there's a lot of talk about more dams. That's a very human thing to do and talk about, but there's not a lot of places to put more dams. So we won't see a lot of new dams in the United States or around the world for that matter. Australia, when they had their big dry back at the turn of this century, they implemented two things that I thought were rather interesting. Most of the big cities now in Australia have desalination plants, and if you look at the cities in Australia, they're all on the coast. These desal plants are not all fueled by renewable energy, however, which is too bad. But if they were fueled by renewable energy, that would be a possible solution to help coastal areas. And also rain harvesting is another thing that could really help. Going back to the environmental justice comment, and unfortunately she's left, one of the big losers in the Southwest are going to be rural communities. And I think this is a big part of the Green New Deal is we got to help rural communities as much as we help anyone else. But the urban centers in the West all have conveyance to these big river systems and can get water that way. But the rural communities don't have access to river water. Or if they do, those rivers are drying up. And they all have fossil groundwater, and that's it. So they're going to be forced, like in many parts of Australia, to start relying more on rainwater harvesting and water reuse and being much more careful about their water. And that means not using it for agricultural purposes the way they've been using it. But that's a big environmental justice situation that will only truly be solved by solving the climate change problem.
We'll take one more question. Down.
So you implied near the end of your talk that because of the fact that the Great Lakes region still has a fairly sufficient water supply, that there might be a change in population dynamics of people perhaps moving back to this area. Is there concern that instead people from southwestern states or areas that are going to be water depleted are going to actually have their eyes on the water of the Great Lakes and start taking that down? And what's being thought? What are the thoughts about what might happen to prevent that?
You know, it was funny because when I moved back from Arizona to Michigan, I grew up as a little kid in Michigan and have pretty serious roots there on my wife's side. And I started giving talks around Michigan. They said I was, jokingly, they'd say, oh, you're a spy from the Southwest. Because indeed, Pat Mulroy, who is probably the most visionary water manager the Southwest has ever known, she ran the Southern Nevada Water Authority, totally on board with climate change. And she has really worked hard to get all the water managers in the Southwest on board in understanding this problem before she retired. And she's still tirelessly doing this. She has been the one to sort of think out of the box about where to get water. And she got Vegas to invest $1 billion to build a deeper drain in Lake Mead so they could get the last drop. $1 billion they spent just to get the last drop if we get into the serious doo-doo. One of the things she talked about was let's get water from the Great Lakes, from the Missouri or from the Mississippi. In reality, when you start looking at it, if the Southwest is going to go for water somewhere else, it's going to go to the Columbia. It's not going to go out here. It's just astronomically expensive to move that water from here to there. So that'll never happen. But since then, I've been moving here, I started to think about the High Plains situation. And Brad Udall, the guy I do a lot of work with, his dad was Mo Udall, and his uncle was Stu Udall. And his brother's a senator, and his cousin's a senator. And so we go to Washington a lot and talk to a lot of staffers and congressmen and women. You know, we just do the thought experiment of a whole lot of states in the United States that have 2 senators and 1 representative and no water. And I worry a lot about the High Plains not having the water they need for what is their only really serious economic engine, agriculture. And I think it's important for us in the Great Lakes to think about what we might be able to do to help that situation. And certainly think about it now so that we don't get in a situation where we do something stupid. You know, but right now, if you've been up to Lake Michigan recently or any of the Great Lakes, they're really high. Nobody likes them when they're that high. Shouldn't we be doing something with that water? When you're in an area like the Midwest, look what happened in the last couple months where we've had all this flooding. We should do something with that water. You know, rather than just creating a disaster, could we somehow recharge aquifers, store that water for when we need it? These are the kind of things we should be talking about regardless whether we let climate change go checked or unchecked. The Colorado River, you know, I mean, we're not going to fill up these reservoirs ever again, I don't think, but we lose a lot of water to evaporation. Should we be thinking about ways to curb that evaporation? Should we be putting the water underground? We can store a lot of water underground in these aquifers. So we need to get out ahead of this, whether we let climate change go or not. Because we're going to end up, you know, as a nation, having to confront that kind of question you just raised. Are we going to build more infrastructure to move water around? And if we do, let's at least do it with renewable energy.